Now we're going to launch it at an angle, but we're going to have it land below the launched angle. So really your situation is going to be like a cliff. You're going to have your original level, okay, and your object is going to be launched at some sort of angle, but it's going to land below. So you can have something here like maybe big building or something over there. And we're going to want to find how far below that original line that this thing lands. Again, everything's going to be the same. Now, if this bottom part didn't exist, you'd just be the previous example. But now we have a little bit further that it's going to fall. But I'm going to help you out because I'm going to tell you some information about this thing. First of all, whatever it is launched at 20 meters per second at 40 degrees. Okay, so I'm saying cannonball is being launched off at 40 degrees. That means that's 40, which means absolutely nothing about this angle here. This is not 40. There's no way you can figure out what it is. Just leave it alone. Now, what are we doing here? Right. That is 50 meters away. So now you know how far the building is, or whatever this object is here that you're hitting. You're shooting it towards it. It's landing below, but this is a certain distance away. This is your dx. This is a really, really powerful statement because really the equation that you've got, dx equals vxt. Well, I have my angle and my initial velocity. I'm going to find vx, and right away I'm going to know my time. I'm going to find my time to get from here to here. Once I know the time to go from here to here, it's the same time to go from here to there, meaning it's the same time to go up to the maximum and fall down to when it hits the wall. So once I find this time, I'm going to find dy, and it's going to tell me the answer directly. I'll show you what I mean. First and always, Vx, 20 cosine of 40 degrees, which ends up equaling 15.3 meters per second. Vy is 20 sine of 40, which ends up equaling 12.9 meters per second. I'm going to use my vxt. So for my second point here, I'm going to go dx equals vxt. dx, I already know it's 50. Vx, I just figured out it's 15.3, so now I can solve it for time. When I do this, time ends up equaling 3.27 seconds. Awesome. I take this time, I'm going to plug it into my dy formula, and it's going to tell me right off. I'm going to use dy equals viyt plus 1/2 at squared. dy is what I'm looking for. Viy, I just found it, 12.9. I know time, 3.27. Plus 1/2, gravity is minus 10, and this, to write it in here, is 3.27 squared. Okay? Solve that. Plug it into your calculator. 12.9 times 3.27 is 42.2. This ends up being subtract 53.5. Get your answer, ends up being minus 11.3 meters. That means that it's 11.3 meters below the original position, or launch position, or whatever you want to call it, but it's 11.3 meters below. Super, super easy question. This, they figure, is supposed to be hard, but look at it. It's so much easier than the last two, just because you have your two equations. But because the fact that it falls a little bit bothers people. Now, if I took this building and I shifted it over to here, the next question that we're going to do is we're going to land a certain level above. It's going to be the exact same procedure. I'm going to tell you how far the object is away. The thing is, it's just going to be here, so it's going to be less distance. You're going to find your dy. When you find your time, you plug it in, and this ends up being a positive. So it's, again, very, very easy. That's what we're going to do next. There you go.